In this example, they want us to identify growth or decay, the domain, the range, the y-intercept, the x-intercept, the asymptote, and the end behavior. So we're going to start by completing our table of values where we're plugging in these x values here for x in our function that they gave us, which is f of x equals 2 to the x power. So 2 to the negative 2 power is the same as 1 over 2 squared, which gives us 1/4. 2 to the negative 1 power is 1 over 2, which is 1/2. 2 to the 0 power, the law of exponents lets us know that anything to the 0 power is equal to 1. 2 to the 1 power is just 2, and 2 squared is 4. So once you have your table of values, you can plug these in, but you can also just plug in your function. I prefer you use Desmos graphing, and it's going to give you a graph similar to this one, where this is our y-axis and this is our x-axis. So because it is increasing from left to right, we know that this is exponential growth. We can also tell because the b that we are given in the function is greater than 1. Now our domain is going to be all possible x values. And we can see as we go to the left, it goes towards negative infinity. And as we go to the right, it goes towards positive infinity. So our domain is going to be all real numbers. Our range is all possible y values. And we can see that it never goes below the x-axis, which is going to make our range y is greater than 0. Our y-intercept is where the graph crosses the y-axis. You can't tell here, but you'll be able to tell in Desmos when you graph it. But we can also use our table of values to see that when x is 0, y is 1. So our y-intercept is at 0, 1. And our x-intercept will be where the graph crosses the x-axis. And we know that it will never cross. So there is no x-intercept. Now our asymptote is the line that the graph approaches but never crosses. And in this case, it's going to get very, 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 very close to the x-axis, but it will never cross it. So the asymptote will be at y equals 0. And then our end behavior, what is going on here, as x approaches negative infinity, y approaches, so as x approaches negative infinity, y is going to approach this x-axis but never cross, so y is going to approach 0. And as x approaches positive infinity, as x continues on this way, our y, x is going to continue to go up, up, and up, so y is going to approach positive infinity. And there you have it.